Good evening, everyone. My name is Susan Pond, and I'm honoured as President of the Royal Society of New South Wales to welcome you to this meeting. We acknowledge the traditional custodians of the lands on which each of us lives, learns, and works. We pay our respect to elders past, present, and emerging. The Society is presenting this lecture online tonight so that we can reach as wide an audience as possible. The recording, for anyone unable to watch in real time, will be made available on the Society's YouTube channel. I welcome the panellists on the screen. Chair of the Society's Program Committee, Christina Slade. Christina, raise your hand. A member of the Program Committee, Bizo. And our speaker for tonight, Michael Blumenstein. I also acknowledge Kate Carruthers, our Zoom master, whose work behind the scenes makes this possible. Professor Michael Blumenstein is Acting Dean of the Faculty of Engineering and IT at the University of Technology, Sydney. We are privileged to have Michael to speak to us on the subject Artificial Intelligence Myths Debunked, how AI is transforming humanity for the global good. We hear and see so much about artificial intelligence these days, it leaves us wondering whether to accept the arguments of the doomsayers or the Pollyannas. Who better to set us on the right path than Michael Blumenstein, who has worked in the AI field before it was the AI field, having worked in the field for more than 30 years. Michael became inspired by the power of creating software through programming and coding in the early 1990s, when he became fascinated by the possibility of creating programs that could learn on their own. At that time, he was pursuing his undergraduate studies at Griffith University in Queensland, where he received his Bachelor of Science Computing in 1995. He subsequently graduated with a Bachelor of Information Technology and first-class honours for his work on developing software to read handwritten characters via neural networks, the precursors of AI, as we know it today. Michael was awarded a PhD in 2001 from Griffith University. His thesis proposed a novel algorithm and document analysis to segment handwritten characters so that handwriting recognition could be processed using artificial intelligence. His research in handwriting recognition and document analysis has been published extensively in national and international journals, and he is the leading authority on this subject in Australia. Since obtaining his PhD, Michael has continued to develop AI algorithms to solve some of the most challenging real-world problems. In the early 2000s, he and his team developed world-first AI technology to detect potentially dangerous currents in ocean beaches. Later, for the second largest local government in Australia, the Gold Coast, Michael developed flood prediction technology to mitigate the effects of flash flooding and climate change. Through a nationally funded research project with state government and industry, Michael also pioneered AI technology to use prediction models for cost-effectively and safely maintaining bridge infrastructure. Michael's work in delivering groundbreaking AI technology continues to have impact through the development of SharkSpotter, a world-first AI-based technology for detecting sharks in the ocean from uncrewed aerial vehicles, or UAVs. I first met Michael when I was chair of the New South Wales Smart Sensing Network in the context of SharkSpotter, which was one of the network's initiatives. He worked with our mutual colleague, Paul Scully-Power, Australia's first astronaut and co-founder of the drone company Little Ripper. The drones were programmed to use Michael's AI software. SharkSpotter was followed by CrocSpotter, another world first developed to protect northern Queensland waterways. Michael's work has been commercialised for use by local government agencies, coastal management authorities, and by industry and commercial applications. Nothing is going to stop AI now. Let's listen to Michael as he tells us about it as a force for good, while no doubt acknowledging that we are in uncharted waters with much to learn. Michael, over to you.
Thank you very much, Susan, and thank you so much for that kind introduction. So I think, Susan, you were very correct in saying that AI is unleashed upon us. It's now here to stay in its form that for some people is, revolutionary, scary. You mentioned doomsayers and the sort of view of what the future holds in potentially a positive or a negative perspective. I would like to focus today, particularly or this evening, on the global good elements of AI, because I think it does get lost a lot in the very visible media attention that AI brings from the negative side. And so I'm going to present today a little bit of a breakdown on where I see the state of AI being, and potentially sort of also clarifying some of the things which in many cases the media doesn't really cover, and I'd like to really make sure that I give people a good sense of where things have come from, and then get a better understanding of where things will be going. And then I'd like to go through some of the work that we've done in creating AI for global good, and some of those that Susan mentioned. So it's an absolute pleasure to be here this evening, and I hope that there'll be some stimulating discussion after the presentation. So for my opening, I'd like to just say, when I talk about the sort of artificial intelligence facts and myths, I want to really tell people from the offset that there's a lot of things that people really don't realize how AI has come to be in this very day of ChatGPT and large language models, which I'm not going to go into in technical detail, but I'll cover a little bit later. AI has been around for a very long time. It's been around longer than we could actually, really fathom. In fact, the precursors to what we see today, and that is the incredible technology that's able to recognize, objects and speak to us as if they were human, was actually really developed as far back as 1943, when McCulloch and Pitts created the very first artificial neuron, which was something of an absolute revolution back in those days, because at that point people were really excited about striving to human intelligence, and the human intelligence symbolized by the brain, and therefore the most complex objects in the universe containing biological neurons, was looked at as the model for how we could create an artificial brain. And that's where the first artificial neuron was born. So when we talk about AI, and it's the last few years that we see this revolution and taking business by storm and academia by storm and the whole of society, what we're actually missing is that there's a very long runway to get to where we are today. And I think one of the things that really has come up as a talking point a lot is that we're fearing where AI will go. And the concept of AGI or general AI technology has come up a lot in terms of the future worries that people have. Well, there is no general AI right now. And the sort of reality is that we're not seeing a very clear picture of when general AI will arrive. So what do I mean by general AI? I mean the fact that at the moment we've got AI technology doing one thing really well. And if we're lucky, two things. But we don't have any AI technology that can go in a broad sense and, like we normally think of a robot that can pick up a cup of coffee, can run, can do calculations, can speak. That would be the embodiment of general AI. We do not have that. And the estimates are that it will, some people say it will be here in 2 to 3 years. Some people say it'll be here in 200 years. Because the reality is that just as those early pioneers who discovered the first artificial neuron, people who are striving for, the current version of general AI are really aspiring to replicate exactly what humans do. So some people argue that the Turing test, which was the test that enabled people to tell the difference between a computer when you speak to it and a human being, has already been passed. So this was, Alan Turing putting this up as a test for have we reached, AI, an AI milestone. Well, ChatGPT has shown that we are getting, as humans, fooled by the type of responses that it's providing when we type in phrases or questions. But we're not there with general AI. And I'd like to just say that, there has been a lot of people who have been in the industry for, say, a few years developing startups or even in large companies that are saying that they have the answer. The reality, there is no silver bullet for AI at the moment. And there is a lot of apprehension around what can actually be delivered. But it's really important for people to realize that the startups that are out there are doing amazing things, but some of them can't offer all the solutions. And certainly the answer isn't always there if you pay more money or if you get the best company or the most well-known company to do something. There is still a lot of work to be done. And at the moment, any real use of AI, say in business, requires a lot of tailoring and a lot of customization that is extremely expensive. But one thing I wanted to highlight, of course, I am from a university, so I have to say that cutting edge technology is actually sitting inside our own universities. And I mean, in Australia, we're in the top 10 universities in the world that have outputs in AI research. In other words, we rank for the quality and quantity of publications from an academic perspective amongst the top 10 in the world. And per capita, that is incredible. But what that suggests is that our concentration of work that we're doing is significant. But of course, as always, the spectre of commercialization and bringing this to a reality is something that we as a country are not doing really well. So I'd like to just reflect on another thing here, so that, on deep learning. And again, I'm not going to go into very specific details about the technology itself, but suffice to say that when I talked about the first neuron in 1943, the next generations of what later became termed neural networks really hit a peak in about 1986, where we actually had the formation of a neural network, so a bunch of artificial neurons put in software that all were interconnected and could be fed information to solve problems, was really at its peak at around 1986. We then went into later on in the 90s and the 2000s, early 2000s, into a bit of a winter, what they call a winter of AI. And the AI winter is when AI gets out of favor, and to the point where I remember giving talks in 2010, and I used the word AI, and people were saying to me, AI is so old-fashioned, I cannot believe you're still using that term. And it made me laugh that now, we can't even get away from AI, no matter where we look, in the media, newspapers, wherever we are. So, but really what I wanted to make the point of is that, without going into the details of the history, the reality was that there were actually many flavors of AI. There was classical AI, symbolic AI. Where we've landed is the dominant AI that we know today really all came from this, what's called connectionist learning, which is the artificial neural network that are loosely inspired by, the interconnected neurons in the human brain. Of course, human brain has 10 to the 11 neurons. We are now striving towards trying to replicate the significant number of interconnections within a software context or even a hardware context, but we're not there yet. And some people believe that when we reach that level of interconnectivity, we'll actually get conscious machines, and that's another really interesting topic to go into from a philosophical perspective. But I just want to make one last point on this slide, is that deep learning was actually the biggest revolution that we saw in 2014, 2015, that was published and in Nature and a few other places around being able to take neural networks to the next level. And this was a type of learning that was able to process large amounts of data and actually start cracking really difficult problems. And particularly in the vision community, where we see people saying that they can have over 90% or even nearly 100% accuracy in, say, diagnosing melanoma from a video, a snapshot of an image of someone's arm or part of their body. That was all powered by deep learning. And that was really the massive revolution that changed the game of AI, and is really what we're seeing is reaping the benefits today in everything that is hyped. It all started with that deep learning. And so when we talk about ChatGPT, which is an amazing technology, and it's now starting to not only become commonplace and people using it, but it's now, people are really worried about where it's going because of the implications of, in education, are people learning because they're using this ChatGPT that can create, things. But we shouldn't forget that although people are absolutely feeling there's peril in ChatGPT and what it might bring in terms of change to society, to business, to education, to the workforce, it actually is all based on what we call large language models, which are, an approach based on deep learning and neural networks, that revolution I mentioned in 2014, which literally is a really advanced, significantly data-hungry version of natural language processing, which also has been around for quite a long time. But the fact is that because of the power of what we're, what's come about in terms of the access to data and the amount of, powerful computers, these algorithms can then function in a way that appears to show that what's generated is absolute magic, and it's actually, human-like in nature. A lot of people don't know that, OpenAI, which is the company that Microsoft is invested in to create ChatGPT, requires the powering of a lot of computers. The estimate is for them to run, it requires in the order of millions of dollars a day by Microsoft to keep the significant size of those computers running to enable what you see on ChatGPT. If you've never tried it, I would strongly suggest to do it. You can even go to Bing, which is the Microsoft's web browser, and it's integrated there, but you can also access it directly from OpenAI. So I just wanted to give that context, because we really need to put everything we're seeing and the concerns about AI in context before we go forward in terms of how we look at AI. So I wanted to also, hopefully you can see these articles on screen. I'm not looking to go into the detail of each of the articles, but I'm just wanting to show you some headlines that occurred in the last couple of years. There are some huge debates around, what really, remember I talked about when are we going to actually reach this general AI area? Well, one of the headlines is that, one of the top neuroscientists who's also very much involved in the AI conversation, Jeff Hawkins, was talking about the fact that, well, it's not really possible for us to get to true AI. So he contends that all this worry is literally unfounded, because we can't get to that true AI until we can actually understand the brain. And at the moment, the human brain, we can only understand to about 10% of what it actually is doing and actually understanding what underpins its operation. So if we're going to be worried about the fact that AI is going to be, taking over humans, well, firstly, perhaps we should look to biology and realize that there are some limitations there that we haven't reached. The other thing is that there was a very lots of confusion about what AI is. So what I showed you in the previous slide was that AI is really, at the moment, what we're seeing is pretty much the manifestation of the biggest revolution in neural networks, which is deep learning, and then later the large language models. But a lot of people associate AI with a lot of other things. Is it data? Is it, classical AI? At the end of the day, today's revolution is based on those two big things that have changed, the deep learning and the large language models. So there's a lot of debate around the issue of even AI terminology. And this is causing lots of problems when people are trying to create regulations and rules around AI, because the definition of it in itself is problematic. And the last thing I wanted to highlight on this slide is the fact that, who is actually winning the AI race. A lot of people, at the moment, the US is probably looked upon as being the front runner, firstly because it's got the largest investment in AI still in the world as a country, but China obviously is hugely nipping at the heels. And that particular slide in 2021 was talking about, the EU as well being in the race, but really it's really two of the countries that are really dominating at the moment. But what we can't forget is that there is a heap of debate around, who's actually, who's really leading, and do we have all the information in front of us as to, and why does it matter? Well, I think for us to strive for innovation, if we want to really be the front runner in a particular area like AI, but we really have to invest in that innovation piece for that to happen. But there are some proponents that are saying, well, let's limit that, like the most recent declaration by a number of experts looking at a 6-month embargo. I mean, if we do this, the potential for us to lose the race, so to speak, and I don't actually see Australia, unfortunately, in any of these rankings, is really of concern, because we, at the end of the day, AI is here. So I think we have to think carefully whether we want to be in the race or we don't. And I would say is that if we are going to be, then we have to step up as a nation to actually make that happen. Now, a couple of other things that have just recently come out, which may be of interest to people, literally overnight before this presentation, while I was putting the finishing touches, we had two big announcements. So one of the things you will see on the slide there is Geoffrey Hinton, one of the fathers of deep learning. Here, it's called the godfather of AI. He literally overnight quit Google because of fears of what the technology can do. So that has sent shockwaves around the community. And literally again, overnight, IBM's CEO announced that they're pausing they're thinking to pause their hiring because they believe they could replace 7,800 jobs with AI. So it's funny, the news cycle is dominated by not so good news stories around where things are going. And the whole concept around doom of AI, as you can see, is in this middle picture is another very clear headline that's coming up. So I think there's a lot to think about in this, and it's not something that's easily solved as a philosophical or as a ethical issue around AI's existence. But we've got to understand that at the end of the day, there is some trade-offs to be had. If we really want to go down the path of innovation, we'll have to see what regulation would look like, and what are the actual problems that people are concerned about. And certainly Geoffrey Hinton there in the photo was concerned about the AI getting in the wrong hands. So let's take a look at just this slide here around. I want to just focus on for a few minutes around ethical AI and some of the concepts of that have been doing the rounds a lot, particularly around how do we carefully navigate the AI landscape. There's a quote there from our former chief scientist, Alan Finkel, which to me, sort of struck me as quite concerning at the time, because, I'm an AI researcher. I know what goes into the efforts to create something that is there to actually do good and do better things. So the tone and narrative around AI in Australia always was set for some reason to start in the negative. And this whole, if you look at the items in italics there around, the darker aspects of AI and the threatens our way of life. I mean, there's some pretty strong statements there. And it's certainly quite a worry when it's put in the context of, let's do something good. Well, how can we, if everything about AI is spoken about by some very noteworthy people as being dark, dooms and gloom. So the terms such as coded bias came out, and there is a big movement, and actually the amount of research being undertaken focusing on the problems not only in ethics but in the bias of how AI systems are created has grown astronomically. In some parts of the world, it's probably might even supersede the amount of research that's actually going in developing the technology. So there are some potential concerns. If when you do research in a university setting, there are clear ethical guidelines around how you create something. There are clear guidelines around for software engineers and professional programmers how things are coded. So I think a lot of this was coming out about the fact that a lot of technology was able to be downloaded and available from the web and could just be used by anyone. Now, in non in an environment where there's no sort of view on ethics and professionalism, just as any industry is, when you're an engineer, you construct a bridge. Computer scientists construct an AI system, but there are people in that discipline that have got significant training in ethics, and it's part of the Australian Computer Society charter that every university in Australia gets accredited for. But there seemed to be this consistent view that there is an unseen bias and unseen problems with the technology because there was a lack of understanding of the technology from the majority of people, particularly those that aren't creating it. So we went into trusted autonomous systems, and look, I think trusted systems are an important element. There is something that we have to think about. At the end of the day, computer scientists can get lost in the fact that what they're creating is not for themselves, it's for users. So obviously the trust of users has to be there. But it sort of reminds me of how, if we're second guessing everything that professionals create, we might be in a situation of where we were, in COVID, where we were creating vaccines and things to protect us, but there were people questioning the science and questioning the integrity of what was being developed. And so there's a reminder of that in all of this, and it's just something that from a computer scientist perspective raises eyebrows. And there's a real big focus on sort of bringing AI and humanizing it. It's no longer a piece of software which normally does the job of what it's supposed to do, just like software in an ATM or software in the cockpit of a 747. But all of a sudden, when it comes to AI, because it's perceived as making decisions and making arbitrary decisions, is all of a sudden assigned a human face and is being humanized. And that's something that's a trend that is growing, and AI is being held accountable in the same way as, I don't know, someone that's just like with there's a judge on a bench making a decision. AI is being put on the same level as a human decision maker, and that is also not really the correct approach, because in many AI systems we do not make the final decision through the AI system. There's always the potential for there being a human in the loop to be more, the AI being more of the supporter of the human rather than taking over the human decision making. So last couple of lines on this slide, just something for food for thought. The concept of overregulation, which is something that has been talked about a lot in many countries, there is the potential for it to also stymie innovation. So that's that balancing act I was talking about, ensuring that there is the right settings for regulation to ensure that innovation can occur. And it's about talking about the precautionary principle versus the innovation principle. If we're worried about every possible thing that AI can do, we're going to run into really big problems, because no one saw ChatGPT coming. So computer scientists saw it coming, but a lot of people did not see it coming. And it was this big surprise. But actually, ChatGPT is just one dot point on a journey for us to get to the holy grail of general AI, which is a very long journey indeed. And it goes up this way, but we're only here. So we've got to make sure that we're in the right frame of mind when we talk about what kind of precautions we're taking, and are they actually needed for the current version of AI. When I talked about humanizing AI, what I meant was there were people that were putting in appeals to the court, trying to say that AI can invent things and can actually be put on as named on a patent. And again, I think this was a move to try and really worry people around saying, see, the AI is out of control. But even the court ruled that you can't really assign ownership of an inventor to a piece of technology. It actually should go to the and this was in the UK, and it's happened in many other places as well around the world, that it can't actually be the AI that's actually doing the invention. Now, interestingly, since that court trial happened and the ruling happened, we have ChatGPT, and now is the generation of generative AI, which is actually creating things. But again, are we assigning inventorship to the computer and the algorithms, or what are we actually deciding is creating the technology? So look, when a lot of this first came out, there was a view of how are we going to move forward around ensuring that we can still innovate with AI, but ensuring that we could harness it through sufficient laws and regulations that won't stifle the innovation. So the UK has been thinking about this. The European Union has thought about this a lot. And of course, at the time, there were contentions around, should we, regulate, how far do we go with the regulation, how much we don't. But interestingly, so the EU plan is now, the draft has been handed down. It's nearly, coming to fruition as a recommendation in relation to the regulation for AI in the EU, and it'll be the first real place of where something that big will be handed down for a whole continent. But interestingly, ChatGPT sort of threw a spanner in the works for the plans, because that was happening since about 2020, 2021, I think. And so what that meant was that what was included as low risk and high risk AI in those sort of regulations that were being formulated at the EU level, a spanner got thrown in the work, because is ChatGPT high risk or not? It is generative, so it creates new things, but will it actually be classified? It can do other things that aren't high risk. So it's really threw a spanner in the work, and it's not going to stymie the work in the European Union, but it will certainly give food for thought around what's coming next. And again, who is going to say when that next innovation is occurring? And it could be, it seems to me that the innovations are getting closer and closer together. I mentioned to you that one of the biggest innovations at the time around neural networks is in 1986. Well, the next real innovation occurred in 2014. Now, that was a big gap. But then you go 2014 to 2022, 23 for ChatGPT, the gap's getting smaller. So innovations will keep happening, and they will be getting closer and closer as the revolutions tick over. But we've got to think about the long-term game rather than trying to adjust every potential law and regulation to the now, because there'll be something new coming around the corner. I want to show a few quick slides before I actually go on to talk about some of the innovations that we've created at UTS. But it's some interesting things that came out of Ipsos, the big market research firm, very recently, and these were also quoted by the Stanford AI Index, which gets reported every year. It's interesting when we talk about trust in AI. As I said, there seems to be quite a lack of it in some countries. And you look at, I'm not sure how well you can see this on your screens, but basically, I'm not sure if you can see my pointer, but Australia sits very closely down the bottom here, around the 35% mark with Canada and the United States, in terms of the trust that people have in the use of AI in companies. And what's interesting is that it sort of can be seen as a bit of a correlation with the perceived understanding that people have of AI. And my point is that from this slide is that when you look at some of the countries that have the biggest trust in AI, we see here in the right-hand corner, we've got China, Saudi Arabia, and India. And their perceived view of their understanding of AI is way out here. So it's interesting, there seems to be a correlation around people's perceived understanding of AI versus their trust in it. It is also interesting that higher income countries have sort of a less correlation around their trust and a lower confidence in it. So some of the sort of views around things that are coming out of the US and even Australia, there may be some good reasons for it. Interesting here on this next slide, products and services using artificial intelligence have more benefits than drawbacks. So in countries like China, Saudi Arabia, and India, there's the highest percentage of confidence that AI will be used for positive things. And in that list, there are some developing countries, and certainly when you go down to the bottom of the list, France, Canada, Netherlands, United States, Germany, Australia, and UK, there's the least, sort of confidence in viewing AI as having more positive than drawbacks. So we as a country are actually way below the global average in how we perceive that, which is quite interesting. And the last one, last slide is another take on this, and whether they, there's a whole bunch of fields listed there for everything from education, employment, all the way to freedom, legal rights, and food, nutrition, environment. And the question that's posed to the people surveyed is, using artificial intelligence, do you think that those areas, in any of those areas, or most of them, would see an improvement with the use of AI? And it was averaged over the 13 areas. Again, the top of the list here, Peru, China, Argentina, Chile, Saudi Arabia, and the bottom, us, United States, Great Britain, because and we're well below the global average. So we've got a bit of an issue here around how AI is perceived by quite a lot of countries that are very prominent in the AI discussion, and yet there are some countries that are really looking forward to the changes that AI will bring. And at the end of the day, it will be interesting to see as these sort of surveys evolve and more research is done into this, whether we can actually find more correlations as to why this is happening. Personally, I actually do think that a lot of it is tied to how many people actually have taken the opportunity to educate themselves on what AI actually is, what it means in the context of companies, businesses, in global settings, in the community, and actually understanding the function of AI rather than just seeing it as this amorphous thing that is mystical and has very little transparency to it. So now that would mean that a lot of people have to do a lot more looking into AI to actually understand it. That would mean upskilling, it would mean better understanding. But that my perception is that the confidence that people are perceiving is that they don't understand it, and this could be an opportunity for education, upskilling to step in to to ensure that there's a better understanding and a better willingness to embrace it. So with that, I just wanted to, and I know probably time will be running out for me soon, but I do want to just talk a little bit about the work that we've done around the sort of global good piece. And I really think it's important to highlight some of this work. So at UTS, we have the Australian Artificial Intelligence Institute. It's the largest collection of technical researchers undertaking AI research and industry-based work in the country in terms of how many staff and PhD students we have. In my faculty, we have over 1,000 PhD students, and probably about 300 to 400 of those are working in some area of AI and data science. And within that, I'm working in the Intelligent Drone Lab when I'm not doing administrative work as the acting dean. The Intelligent Drone Lab is the first of a kind lab that is focusing on R&D for putting the intelligent elements into uncrewed aerial vehicles or drones. And so the R&D sort of focuses on the computer vision and machine learning aspects, and we're very much looking at how we can use the technology to empower drones to do things that are very sophisticated around vision systems and understanding of the environment to solve big challenges. And so one of the biggest group of challenges that we've encountered is the areas of one of the first big applications that our drone lab was tasked with, and as Susan mentioned in the opening, was the SharkSpotter technology that we created. And we created that with an industry partner called the Ripper Corporation to actually empower lifeguards to use drones to detect sharks on beaches and to actually understand where the dangers lie on a beach. And we've done other technology from Croc Spotter, Distress Spotter, and even Rip Spotter to try and understand how the technology can be used and is evolving. So I don't want to concentrate on the last two, but I'm going to talk a little bit about SharkSpotter and Croc Spotter in more detail. And particularly, I wanted to highlight the fact that we were very fortunate at the time that we created it as a world first, and it actually was derived from a need that Australia had, particularly in states like New South Wales, South Australia, and Western Australia, to mitigate against the shark problem. And of course, the shark problem is not actually a problem. It's actually the fact that humans like to go into sharks' territories. And so we need to find a way to make the beaches safe, but also safe for the environment and the ecosystems, such as the sharks, as well as the people that share those oceans. So I always put up this slide, and this is the one about non-automated shark detection. And if you look at these three images, I know it may not be so easily visible on your screens if you're looking at it from home or on a laptop, but in some of these images you'll be able to see where the shark's located pretty well visibly. In other areas it may be very difficult to do so. So I think you can see on the left-hand side, you can see it. On the one on the right-hand side, maybe. The one on the bottom, probably not. But there is a shark in every single one of those photos, and basically, they are visible, but not necessarily to the human eye. And one of the problems which we tried to address was to mitigate the fact that helicopters were being used to spot sharks with binoculars by a human, and the success rate of that in terms of percentage was only 20%. Now, so you can imagine that if you're looking for danger and trying to save lives, lifeguards, it's a tough job, particularly with glare, with other things. But imagine if you can only do it at a 20% accuracy. So what we did was we were asked, and we actually got some federal funding for it. We got some state funding and also some funding directly with the industry partner, Ripper Corporation, to develop the first ever customized end-to-end deep learning based technology for spotting sharks. So I wanted to say that, it is customized. So a lot of people always ask, did you use existing technology? we had to create something specific, and it had to be very tailored to that particular problem. But remember, I was talking about earlier in my presentation about deep learning and how important that is to the revolution of the technology we see today in AI. Well, this is what we used all those years ago to get started to underpin the technology, which is now SharkSpotter. So firstly, it had to be intelligent, had to be real time, and it was using video frames captured by the drone's camera to analyze the imagery and understand. So we were trying to augment the human performance. And as I said before, human performance was only at 20%, 15, 20% from someone with binoculars from a helicopter. We got it to the point of over 90% accuracy, and we can detect not just sharks, but 16 objects in total. So this was the general scheme. We have a drone here. We have the camera on board. We have the ability to relay the footage to the device that the lifesaver is holding. But what they see on their screen as they control their drone gets a feed not only of video that is able to see what's happening and what the drone is seeing, but the whole big part of it was that it could actually create squares around the shapes that symbolize certain things. So whether it's sharks, whether it's a person like a surfer here in the corner, other type of marine life and so forth. And, there was a very simple interface that was used on an app where you start the detection and you just keep going. And the question here is, what do you do once you see one of these? And that's always the question I get asked. And this is the whole point, that we are empowering the lifesavers. We're empowering the lifeguards to actually see what's going on the beach, but without them having to squint and look hard. We bring to them the potential danger, for example, a shark, and say the computer is saying this is the threat. So can you actually, here, then we get, and this is the thing I was talking about earlier, the human in the loop aspect, getting the human to resolve what to do in terms of the decision. Do we send out a lifeboat? Do we send out, a helicopter? Do we rescue someone? Is there a false alarm? So that's sort of the technology there. This is a bit of a story to date. I might just skip on this, but it actually all started back in 2017, and we'd at the time deployed at about 15 New South Wales beaches and Queensland beaches. But in general, what we've actually, this is sort of the time frame very much compressed. We actually conducted trials here in New South Wales, in Queensland. There were also trials and technology deployed overseas, including at Reunion Island, which is in the Indian Ocean. And unfortunately, Reunion Island's second name is Shark Island because there's so many sharks there that you cannot actually even go out to swim. So that we got really good experience, and primarily this has been deployed here in Australia, but we got really good experience in looking at opportunities and deploying it elsewhere internationally and so forth as well. And one of the things we developed, just as a bit of an aside, was this SharkSpotter cloud solution where we could actually do all the processing of SharkSpotter not on the box, so to speak, because there was the box which had to be brought onto the beach was a big computer that was connected to the drone and could process the imagery. But that wasn't what we wanted. In the end, we wanted to see whether we could develop something like a cloud solution, which could be all the computation will be done, without lugging around big hardware. And that's just, something that was, again, first of its kind and was able to process the frames really quickly. And that is the key here, is that what you're doing is real time. So if the drone spots a shark, it must have the possibility to immediately alert the human in the loop, because if you don't, then the problem is that you could miss a very dangerous situation that can't be mitigated against. So the next slide here, and hopefully you can see this on your screens, is the video of SharkSpotter in action. So there's the camera there. There was also, you could see when it was taking off, there's this deployable pod, which is actually a rescue device. And it actually was the subject of the first ever, and here you can see it actually detecting in action whales, sharks, dolphins. But that, I just want to talk on that pod a little bit. It was actually a pod that was actually the feature of the very first ever worldwide rescue of people stuck in a rip via drone. And that was broadcast very widely in the media at the time. And so the Ripper Corporation and the industry partner that we worked with got a lot of great press on that. But yeah, here you can see many examples of drone footage where it's been deployed and the level of quality of the detection that it's making. And again, this is like a recommendation to the lifeguard and lifesaver. I'm not going to spend too much time on this part. I mentioned to you before that we actually ended up having the development of apps that people could even log in and use, and these apps are actually available on the App Store. But the whole point of this was that the ultra low latency element, we developed this. We talk about ensuring that you can mitigate from, like in that last shot from that last video, a surfer being right next to a shark. We have to really ensure that we're speedily, as quickly as possible, giving the information about a danger back to shore. So this whole concept of creating cloud-based solution triggered the ultra low latency technology that we developed, so that the detection could occur in the cloud almost within 1 second. And that was really a hard thing to do when you have to process not only the video that's coming in, but actually use the AI to do the detection. That all takes time, and although it's not hours, every second counts when you're actually detecting danger on the beach. So that was just some of the technology that we created there. Suffice to say, we were very fortunate at the time. We got lots of awards at the national level. We also got some awards at the international level with the Asia Pacific Information and Communication Technology Awards. We also got some awards with from the actual Uncrewed Aerial Vehicle industry in 2020. So my colleagues and I, so this is Associate Professor Navin Sharma, who's the technical lead on the team, and many other team members worked to get SharkSpotter to a stage which was really significant enough to also be given recognition from our peers. Also, I cannot emphasize how much media attention SharkSpotter got, and it's still attracting attention to this day. The National Geographic article here, which I mentioned around the two teenagers that were saved from drowning. So again, it was the world's first ever. This has happened in Ballina, world first of a drone deploying inflatable technology to save people. This was pretty impressive. Worldwide coverage. We were very excited with the fact that there was so much interest in this, even though sharks on their own are a problem not for every single country in the world, but certainly Australia and South Africa and many other places. But just I think the power of using drones to support safety on the beach and doing something that will make people feel more confident about the technology being there to protect, in a sense, was something that was really, really positive. So again, lots of recognition in the media. I won't go through all these, but in 2021, it was voted as #1 in the top 10 life-saving Australian inventions. And I suppose this is where I wanted to make sure that the emphasis really lies around the AI for global good piece. If we focus on the opposite, we miss some of the really significant positive things that AI brings in terms of the technology that's there to assist and support humanity. We also got some publications, and we continue to publish in this area. So academically, it was hard to publish because of the commercial nature of some of the work that was done, but it's really important to report on some of the work that was first achieved by SharkSpotter. So I'm mindful of time, and so what I wanted to just very quickly do is illustrate a few more of these examples of the technology that we've created. SharkSpotter was a very interesting one. We live demoed at a World of Drones Congress in 2019 in Brisbane, but it was there to support, the ability to mitigate a problem that the Department of the Environment had in Queensland, particularly northern Queensland, around crocodiles that were, being, sort of, again, going too close to human locations, or it could be the other way around, humans getting too close to crocodile habitat. But there was some worry about ensuring where crocodiles were at a particular time, where sometimes they would even end up on the beach. And so some of the work we did was to look at different settings for where crocodiles are in the northern Queensland setting, and seeing whether we could take the technology that we created for SharkSpotter and take it into a different environment. Now, crocodiles still in water, but they are in a different environment, and particularly the waterways that we see, and you'll see it in these examples as this video is running, that, some of the water is murky, some of it's, indistinguishable from the crocodile itself. A lot of these shots, though, are pretty reasonable, but depending on your height, depending on your angle, very hard sometimes to actually get the technology to recognize things at a great accuracy. So again, we ended up being quite a high level of accuracy and monitoring these animals to the point that could give some valuable information to the authorities. I have a few more examples. I'm just going to rush through them a little bit, but he was a pilot for the work we were looking at doing, and we haven't evolved this yet, but the concept of distress spotter, seeing humans in distress in ocean settings, in beach environments. This footage was an example of how the rescue occurred around that inflatable pod that was deployed into the ocean, and this is this type of technology where the drone is really the detector and the immediate responder, but the lifeguards and deployment of boats and actual other vehicles to rescue the people is a really good harmonious technology human mix to solve the challenge. We were also asked to do other technologies such as, sorry, I'll just quickly go back here, was the work we did where people wanted to know during swimming carnivals for people's safety, to understand where swimmers were located. So this was not about identifying individuals or breach of privacy or anything. This was just looking at the safety of swimmers in professional and or practice runs of carnival work for swimming contests, and this is really good because the authorities again get an understanding of where surfers are located, where the swimmers are located, and so you could see that the technology, there was certainly an evolution of the technology to encompass different types of problems, and we even got to the point where we were looking at thermal imaging for looking at wildlife at night, and we could actually use different types of imagery, so not standard what we call RGB, video-based technology in the day, but actually being able to detect wildlife in their natural habitats when they can be sometimes nocturnal animals that are out and can be counted for the purpose, again, for environmental settings. Interesting, there's so many other case studies that I could show. We actually won a New South Wales COVID-19 District Challenge grant. And one of the successful bid that we submitted was at the time, and this is interesting now in the context of post-COVID, how we're not really looking at distancing as an important element. But in this challenge, we actually proposed that we could use technology to make people stay safe distance by measuring whether people were actually in crowded areas, keeping that safe distance. And again, this, it was a pilot, but it just shows the potential for how it can be used with, in all sorts of settings, including in pandemic settings. And at the time, the New South Wales government was quite supportive of being able to use the technology in that way. But we've also been able to adapt the technology to quite a number of other applications, included the real-time monitoring of big assets, for example, wind farms, and also power stations and poles that are sort of having the need to have recurring maintenance in areas of where they're not accessible, or that it takes a lot of money to actually maintain these structures. So you can use drones for that, and you can use drones to detect damage on the blades in wind farms and make an assessment, and then easily do a run where the technology automatically captures the imagery and diagnoses whether maintenance is required without having to deploy someone to actually physically identify it. I think that one of the things that I'm most proud of most recently, particularly when we talk about global good, is we recently, about a year ago, we got awarded a Oz for Innovation grant supported by DFAT to deploy this technology for humanitarian purposes, but in a different context, and that was for search and rescue in Vietnam after disasters such as floods. And so we took the original SharkSpotter technology and adapted it to the Vietnamese context. And that means retraining, but it means using the technology to be able to, for example, identify whether someone needs to be rescued in a post-disaster setting. Interestingly, just before, a couple of weeks before this lecture, I actually traveled to Vietnam, and we handed over the technology to, I think it's Hoa Binh province, where we did the handover and transfer of the technology to the Vietnamese municipality, who can then take it and deploy it and actually adapt the technology. So we transferred the technology to a certain level, but they were going to adapt it so that it could be used by their local authorities. And they were extremely grateful. And the local government senior officials came, and we had a ceremony that was really that was attended by CSIRO and who administers the DFAT Oz for Innovation grants. And then we had a subsequent event with the Consul General as well from Ho Chi Minh City. And what it illustrates is that this technology can be really deployed in a multifaceted way to create ways in which we can help people in distress, and also help countries that don't have that technology at their disposal, and transfer the technology for them to use. The last thing before I wrap up is some opportunities came up with us, and this is where it goes into sort of the more, again, multiple application potential for this is actually detecting drones themselves by using some sort of AI technology. And what would be the purpose of that? Well, I mean, one of the purposes of this is just a demonstration of the technology that we entered into a competition, and we rated really highly into a very good academic publication out of it. But the reality was that this data set was trying to distinguish between the drone and the bird, and we succeeded in doing that really well. And by the way, this example comes from a few years back, but we now have deployed the technology to the next level, which is, I move to this next demo here, is where we're trying to actually detect a tiny, drone in the distance. And now we can do this still at very high accuracy. And as you know, that when drones enter public space, or even things like airport space, these are very dangerous for planes, for people. We've now developed technology which we've actually transferred to another. A company that we work with, a different company, we translated the technology that they've now commercialized and used to be able to detect these drones in public safety and security settings. So we're really, it's very exciting that, again, we've been able to take another example where the evolution of our intelligent drone-based technology can be used for other type of applications. So that sort of reaches the end of my presentation, and I've whizzed through a lot of those application technology, but there's, it's been a really interesting journey to see how we can use some of this in different ways. Started at sharks, ended at public safety and security for drone detection. It's interesting, and there are many other applications between. A lot of them are AI-based and actually are there to serve and create a better environment for humans and the community and humanity. So I hope I've given a bit of a sense of that, and I really welcome questions, and thank you very much for your attention.
Michael, I'd like to really thank you for a fascinating talk and presentation, and I certainly would, applaud that presentation. It was fascinating. We have a number of questions, and I will ask these out now. So just looking at the Q&A. So starting with a question from Kate, what jobs do you think will change or even disappear due to AI?
That's a question that comes around a lot, and I think the clues in that are already being seen in some of those statements I made in the presentation around what IBM is thinking. They're looking at sort of what they call, in inverted commas, back office jobs, and that means things that can be, things that people are doing which can be solved through automation, and repetitive things that will that frankly for humans in the long term can get tired, can make mistakes. Companies unfortunately seeing, or fortunately, depending on which perspective you have, that these type of technologies can easily address those issues, but maintaining accuracy. Some of the, people are talking about things like, people in administrative roles who no longer have to write emails anymore because ChatGPT can write one for you. I visited Google this morning for a presentation on their latest technology, and Google is unfortunately behind the 8 ball now because Microsoft has trumped them with ChatGPT, but they're still got the similar technology in their repertoire, and they were talking about presentations creating themselves. So people who would do PowerPoint presentations, people who write emails formally inviting people to an event, people who are taking minutes of meetings. This will be, their view is that their technology can do that already now without the need of human intervention. Some HR functions, and potentially even areas in the legal profession, for example, where there is a lot of the sort of work at the clerk level requires gathering of information and data. As we've already seen, ChatGPT and other technologies are harvesting that work and coming up with in some cases reasonable conclusions on the basis of material that's been sourced from multiple places. So generally speaking, I don't look at it as jobs going. I look at it as there being more jobs created that enable the development of higher level, more devotion of humans to higher level jobs that require human input. And I think that's going to be the focus as we move away from some of the jobs that are automated.
Great, thank you. Look, and I think one industry that will ChatGPT will kill off, and those will be the FAHMS that are out there.
Indeed,
but
education,
big one. I feel sorry for those folks now. But another question from Kate also said, what steps do you think Australia needs to take to be competitive in the AI space?
Well, this is the thing. I personally view us as, and I mentioned this during one of the slides that came up, we're in the top 10 in the world per capita in terms of our intellectual output on development of AI technology. But for some reason, we're not the ones developing the technology. We're not Microsoft, we're not Google. We create startups, but at the end of the day, we're still not in that space. So, to really position, so there's two ways. There are some people who believe we should not worry about positioning ourselves as leaders in the technical space, but we should just focus on the regulation, the responsible AI, the ethical elements. I think that's, you know, in my opinion, that's not where the creativity lies. Okay, the creativity lies in us developing new things through creativity and innovation by evolving the technology. If we could harness the ability of our academic outputs, which are world-class, and ensuring that a pathway is given for translating that the research, which, by the way, is where most of these companies have come up with their technologies. They haven't come up with it themselves. The likes of Meta and Google and Microsoft, this has all come out of, you know, research labs. You know, people like Jeffrey Hinton, you know, who's an academic. What we need to do is have a better pathway to support researchers and other, startups and our ecosystem to develop the technology that can be deployed, and we sell it to the rest of the world. A lot of people think that's not possible, but at the end of the day, a disruption like OpenAI happened, and it took a lot of people by surprise. It is possible to be in that space, but we really need to have an ecosystem that's nurtured that will allow that to happen.
I'm going to roll two questions together. Peter Baum and Margaret Somerville have asked sort of similar questions. That one in your talk that suggesting that AI is not harmful yet, but that does that mean that further developments might take us in any direction, and you know, some of which might be beneficial, but some of which might be truly harmful. And Margaret has asked the question, you know, what harms do you see as possibilities from these technologies? So where do you see the harms coming from, potentially? Anyway, over to you.
Yeah, so look, it's a really good question. I mean, I think where people are the most worried, and I wish I could draw a little line, you know, where we go from artificial neuron in 1943 to general AI here. There's a bit of a mountain to climb to get there. I think a lot of people are worried about the general AI, or the convergence of the technology to become self-aware, you know, a la the Terminator type movies and the end of days type conversation about AI. I really do think that is something that we will, you know, naturally we are already doing things like regulation of the technology to the point where we're very much aware of the guardrails required. It's happening in Europe. It's happening here. It's happening around the world. So I think the worst possible scenario that people are worried about is that singularity, that self-awareness, where the technology will take over, and then actually do harm on us, because that's what everyone perceives will happen. That's already an assumption. The assumption is that, you know, if we get to that stage, the first thing the machines will do will want to close us down. And a lot of people, including some of the biggest names in the area, like Jan LeCun, who's the chief AI person in Meta or Facebook, is saying, you know, that's not how we've developed systems, and that's not how the systems would naturally go. So I think that's the biggest worry, I think, is that the harm will be of machines that take over because they've become self-aware and they know that their natural instinct is to conquer the humans that have created them in the first place. I think the other thing that people really are worried about is this whole business of the use of AI in defense. And at the end of the day, whether we like it or not, it is already happening. You know, that there is AI augmented technology that's happening in defense. I'm not saying necessarily in Australia, but certainly that's why we've got things like the Trusted Autonomous Systems CRC that was developed in conjunction with industry partners and government to ensure that there's an overview of that, to ensure that technology is not let loose and let wild. So I think, you know, and then you go to the other type of harms, which I think is where the current concern is around ChatGPT and misinformation and providing the wrong thing. But that type of harm, I think, is something that we need to better understand the context of our history. I mean, you know, there have been quotes about people saying that there shouldn't be books printed. You know, these were hundreds of years ago because, you know, the people are getting too much power in their hands by learning. I see this again when people talk about the ChatGPT going wild around misinformation, but there has to be a human element to the distinction of what is and what isn't correct, and I think part of that is going to resolve itself as we adapt to this new technology. So I would say that's probably on the lowest end of the harm scale, and the highest being that self-awareness that I was talking about. But then the defense and autonomy of technology to do things in that space is probably the big one. But the challenge here with AI is that ChatGPT came out for some people out of nowhere. We don't know what that next evolution necessarily will be and how quickly we'll get here. But the main thing is to be able to understand the context that we're not finished yet with the development of AI. And rather than trying to put laws and regulations in for every iteration of AI, we should be having a longer term view of how we work with it in society, in education, in industry, to ensure that it's doing what it was supposed to do, which is to help us in doing things better.
Look, and just to riff off that, there are two questions in the chat that are very related. Kylux has asked about, you know, criminal networks, and given their resources, you know, how can we guard against nefarious applications? And Tibor Molnar has asked something very similar about, you know, AI falling into the wrong hands.
Mm-hmm.
And so what can be done to minimize, I guess, that misuse of a tool that can be used for good?
I think the answer to those questions lie in things that we're seeing already now in areas such as cybersecurity. Now, interestingly, AI now, and I'll reference my visit to Google HQ in Sydney this morning, was talking about what they were doing around AI-enabled cybersecurity, but I'm not going to go down that path. What I'm going to give an example of is that people are now, you know, getting scam text messages. They're being phished through, I mean, PHISHED, through emails and being asked to click on links. So we're already seeing that in the cybersecurity space, where unfortunately the same technology that's being used to protect us from cyber problems are being used by the hackers to actually, you know, enter our sphere of living on our computers for recreation, for our business, and for education. So unfortunately, what I see very short term is this arms race around, you know, once the bad guys get this technology, we need to create this technology. And we saw it in antivirus software, where every time a new virus came out, we had to, you know, get the next version and so forth. But notice that it's now seamless within our operating systems. If you use a Mac, or good on you, hardly any viruses there anyway. But if you use a Windows system, it's, you know, I don't know too many people these days that just get viruses by plugging in the USB stick or downloading something from the web, because now we've got very sophisticated technology. And I'm not saying it's finished, but the arms race has sort of slowed down in that area. So what will happen with AI is the same thing. We're worried about it now because, you know, the bad guys can use this novel technology for bad, and it's so fresh that we don't have a way to mitigate against it. But the technology will come to ensure that that's done safely, and I really don't want to reference Google again today, but in the talks this morning, they were talking about how they're creating the environment to ensure that negative use of AI and theft of data and ensuring privacy and so forth is very much the priority. So even these big companies are thinking very carefully about ensuring that when they develop their products for AI, it's already built-in mitigations are there to ensure that the bad guys have the least possibility to penetrate. But at the end of the day, because it's fresh, because the technology is new, there will be this arms race initially that will then end by having sufficient technology to mitigate against it, so that we can carry on normally until the next ChatGPT arrives.
Fantastic. And we have a little bit of a technical question for you. This is from Emeritus. The SharkSpotter drone has 3 GPS antennas. does it use GPS for attitude as well as position?
So when you say, you mean altitude as in, when you say altitude, obviously it's lift, but in terms of position, you mean its location in XY coordinates?
Well, in said attitude, which I believe is a flight tool, isn't it?
Right. Not altitude.
Not altitude.
So look, the drone itself that we've used has already inbuilt GPS technology that comes stock standard with the drone. We haven't augmented that in any way, because basically the hardware, we have augmented it in only the sense that we've created a deployable device that can launch the inflatable raft. We also have fitted the drone with high resolution cameras which don't come stock standard, but all the other technology that's on there is what comes stock standard on out of the box sort of drones, unless there's a specific application that demands it. So generally speaking, there is nothing different from what's out of the box.
Look, and Michael, I'd just like to finish just by thanking you. I know that we have Emeritus Professor Christine Slade to deliver our vote of thanks. But I just wanted to make one, and he's just pull it up. It's questions about attitude, which means orientation and needs 3 independent GPS solutions.
Yeah.
So that's his.
Thank you. Yep. Thanks for that.
But I guess one of the remarks I was going to make about your talk, and I had some questions in mind, but I think you really remarked about the importance of the human piece and interaction in the use of any technology, and that seems to me to be critical in the arguments and the discussions around the use of AI, and not to forget that the use of AI, such as with SharkSpotter. That it is a tool, but it does require then at some point a human to make a decision about whether to act or not, and that's about looking at the data, looking at the information, and facilitating that piece. So I think that's that critical bit, really, that these are tools and really can be useful. So again, thank you.
If I could just make a comment quickly on that, with the drones, they aren't the only thing that's autonomous about them. Is the technology to view the sharks. The actual control of the drones is not autonomous, not the ones we use. They're in the hands of the lifeguards or the lifesavers they're controlling them, right? So the human in the loop is there, and that human element is so important when it comes to the trust of what's being done with the technology.
Brilliant. Chrissy, over to you.
Lewis, when you proposed Michael's talk, we knew it would be excellent. Michael, as you know, is characterized by quite extraordinarily elegantly titled publications. He can look at mindfulness, is it the opposite of mind wandering, not bird-brained, chickens solving novel timing problems. So he really knows what's interesting. And we knew that your work would be very interesting, but I don't think we had any idea that we'd managed to have you timed at a period where artificial intelligence, ChatGPT, would be at such a premium. In fact, I met yesterday a very senior policy person who said to me, oh my God, 3 weeks ago, I didn't know that I ought to be worried about AI, and now I really am. So our timing is perfect. We've had Elon Musk, Geoffrey Hinton, Yuval Harari is in The Economist this week talking about the particular issues of artificial intelligence with LLM. So it's suddenly become a very strong issue. So we're very, very lucky that we'd managed to line you up for this week. And I'm very, very grateful. And I think probably what's really important is that you've reminded us that new technology is always frightening. When the publishers came, people said this would be at the end of civilization as we knew it. And indeed, I think this new technology, as you reminds us, particularly ChatGPT with its extraordinary power, is something that we need to see as something which is going to help us. We need to be thinking about what difference that can make to our ways of teaching. Perhaps we need to do more Socratic questioning. Certainly, if it means that we don't have to mark quite so many repetitive essays, it possibly has its upside. I think what you were talking of, two things really I thought were very important. Your concerns about over-regulation and the tension between innovation and risk. And I think they are important. We've got to get both that balance right. And I'm not sure how we do it, but I think your examples of working with drones are just extraordinary. And we know drones are going to be transformational in your area, but also we know that drones are delivering drugs in remote areas. They are transformational. And we need to be being as positive about them as possible. I was fascinated by your remark about the Ipsos survey, that the wealthier the country, this is a rough gloss, the greater the concern and distrust of artificial intelligence. I suppose that's probably tied in the cases that you're looking at to issues of concerns about privacy. I might be wrong, but that's what I thought. But look, I want to thank you very much, because I think this has been, I'm sure that Lewis had no idea that this was all going to blow up this week. He couldn't have known, but it really has blown up, and it's been a really important talk for us. And now I'll hand over to Susan to formally close the meeting.
Thank you.
Thank you, Christy. I close the meeting by thanking Michael, the Royal Society of New South Wales members who made the evening possible, and the audience for their perceptive questions. As Christy said, we've been treated to a great example of Australian ingenuity being applied in particular to Australian problems such as sharks, crocodiles, and distressed surfers. But the Royal Society of New South Wales is committed to mobilising the transformative power of knowledge and multidisciplinary expertise for public good. Tonight is a great example of how the Society works to deliver on that purpose. I wish everybody a good evening.